Hello and welcome to our second part of Search System webinar. I am Can Öcal, Marketing Manager of ERGIL GmbH. Here with me are Technical and Engineering Manager Mr. Tunç Türeli and our Technical Manager Mr. Mohammed Hassan. As many of you familiar, we as ERGIL are an energy, water, marine and mining industry focused company that provide various kind of products for storage tank terminals, pipelines, refineries, chemical and industrial plants, and electricity and alternative energy. Today, we are here to answer all of your technical questions, such as surge vessels type, when it's needed, important parameters, specifications, and engineering details. So, we will start with Mr. Mohammed Hassan.
Hello and welcome to our webinar today on surge protection systems. I am Mohammed Hassan, Technical Manager of our company ERGIL. I will start the first part of this webinar and we will continue with the second part with my colleague, Mr. Tunç Türeli, our Senior Design and Technical Manager. For the first part, I will try to give more information and introduction to water hammer, causes of water hammering, and most effective surge protection systems, which is surge vessels. The water hammer is a pressure surge or a wave that occurs where there is a sudden moment change of a fluid. The motion of the fluid is forced by stop or change direction within enclosed space. If we want to get an example for water hammering case, it's like in moving train with constant speed. When the sudden stop caused by barrier or accident, we can see the effects from below pictures. The most common cases of this changes in moments is sudden closing of a valve on a pipeline. When this occurs, a loud hammering noise will be proceed and strong vibration will be sent through the pipe. From that, it's getting the name of water hammer or water hammering. The pressure waves proceed from this event can cause damage to pipeline and the systems. The large increase in the pressure can cause pipes crack, and in some cases, pressure explosions on weak part of the system. Next. In this slide, we will discuss on water hammer causes. The most and the worst case analyzed is the power failure, because when it's occur, the second two items will occur directly, which is pump startup and shutting down, rapid closing of valves. These two cases will be generated by power failure. So the power failure is worst case analyzed. And we have also the second case is pump start up and shut down. And also rapid closing of the valves is most and important causes of the hammering. And also we can include the sudden change of the direction of the fluid. It can be upstream or downstream, and direction turns by elbows or the direction of the pipeline. This is also have effect on the hammering system and can accredite waves. And also air and vacuum combinations, it takes its rules on accrediting the water hammer. And an analysis of the water hammer will include calculating the critical time, determining the maximum pressure increase, and selecting a method of sort production type. Next, please. The results of the water hammers, we can explain it as the front. When the liquid flow is suddenly changed and a force main, a pressure wave is generated, which rapidly travels entire the length of the transfer line and back to the point of the change. That's mean when we will have a surge wave, it will not appear. And when it's rapidly, we have these waves, it will be turned around of the transfer line. And the results of these waves and the pressures, it may result with environmental damage. The environmental damage are almost caused by bursting of the system parts, personal injury, even human deaths, as we have in the right side some pictures of the accidents caused by hammer explosion or pressure explosion of the part of the pipelines. Also, we will force a leak of the system and water demand. This is caused by damaging hydraulic components like pumps, pipeline equipment, and results low velocity of flow. And also we have the maintenance cost because the high pressure causing deformation or crack in the pipeline, and the low pressure also causing a caving in of the pipeline. And also we can list the valves and fittings, slam and deformations. And also in additional, we have insurance and additional charges. To add to the above mentioned issues such as equipment damage, operational halts, maintenance costs, and pretty much charges will be raised. Second piece. Some ineffective solutions for the water hammer, which was used in the past and it's using, but we can list these solutions as not 100% effective solutions. From these solutions, we can list the pump flywheels, but these solutions increase of energy, cannot be used for all pumps, and accordate a balance of the wheel, and also it's ineffective for the valves and the power failures. So we don't have a 100% solution with the pump flywheel. Secondly, we can list vacuum breaker and surge valves, And the case of this solution is more to be installed on the pipeline and require high maintenance, long reaction times. And also we have variable frequency drive, which is named by VFD. It's effective for the normal operations and controlling the pumps during startup and shutdown, but also it's not, and it is ineffective for valves and power failures. And last solution, in the past, there was stand water towers or pipes used for solutions. But this is required a large structure and it's expensive solutions. So the most effective solution for the water hammering is surge vessels. Surge vessels is a balancing reservoir at the downstream side of the liquid transfer pipeline. its feeders, dam or barrage, absorb sudden raises of pressure as well as quickly provide extra water requirements into the system. ERGIL is global specialist in engineering, design, and manufacturing of the surge vessels. Two types of surge vessel which are categorized as a bladder type and compressed air type. Both types can be designed vertically or on horizontal settlement. The general features of ERGIL surge vessels. First, we can list in-house senior design capability of pressure vessels and experience over 30 years on the field to study the surge analysis reports and provide more active surge protection and control system. And also, ERGIL have capabilities are available from 200 liters to 120,000 liters capacity of surge vessels and surge protection systems. ERGIL surge vessels designed according to ASME with U and R stamps, and also capabilities to design according to PED EN 13445 and PD 5500 and AD 2000, and another companies and countries set specifications and standards can be followed by requirements of the projects and the end users. Service up to 14 bars and above for the compressor air type vessels. Bladders are made of material according to service requirements and operational requirements. Service to agriculture, petroleum, dissemination industry, and water supply system. And ERGIL provides complete solution with vessels and needed equipment. So we have categorized our surge vessel in two categories, the main two categories. The first is a bladder type surge vessels. What we mean and what is the method of operation of the bladder type surge vessel? A bladder surge vessel is a surge control device installed within internal bladder. A pre-charge pressure is calculated to give the required elasticity to push the water into the system following the surge wave. As there is no connect between the compressed air and the water, and there is no dissolution between them. So the pre-charge pressure is inside the bladder, or it can be outside the bladder, and a method of operation and balancing the waves is making the blanketing as a balloon inside the vessel. So the vessel is designed as a pressure vessel and installed with suitable designed and manufactured bladder inside. The second type is compressed type surge vessels. The compressed type vessels are commonly arranged with a compressor or a compressors. We may need more than one compressor to provide additional air in the tank if the liquid level raises above the normal condition. The compressor air gives the blanketing on the surge waves that connected between compressed air and the water. The compressed air gives the blanketing against the wave, the surge wave, and the hammer waves. If you want to make a compression between the bladder type surge vessels and the compressed type vessel. We can list the above for the bladder type. Bladder type surge vessel is specially designed with internal bladder and can be designed as air in bladder or water in bladder. The bladder type surge vessel can be used for both hammer balance or water supply to the system. No need to provide compressed air by air service and permit compressors or any lever system to provide the air. So we have to compress the bladder with pressure and put in the operation. Immediate reaction time following a pump shutdown or power cut. There is no gas dissolution in the water in the system. The tank material is chosen compatible with the liquid or lined internally with suitable paint or lined material suitable for drinking water or potable water if we using an air in bladder type. And also it can be designed and manufactured both vertical and horizontal. And if we come to the compressed air type surge vessel, to achieve the system pressure balance, it must be designed with control system. This system must be carefully designed to achieve the limit of the balancing of the waves and the water hammer limits. It's equipped with compressors, air receiver, sonolite valves, measuring equipments, and control valves. The control system is activated on compressed air volume in order to maintain the required elasticity and blanketing. Security and alarm system are also required in event of the system failures. The change in level detected by level instrument. The operation of the compressor and the solenoid air release valves are controlled by suitable control panel. If it will be used in portable water service, air filter have to be fitted on the discharge of the compressor. So when we are compressing air inside the vessel, we have to equip our compressor with suitable filters, oil filters, and particle filters to prevent that oils to be in contact with the water. Next, please. And if we want to list our advantage or ERGIL advantage or surge controlling system, this is why we need it. The controlling system, it's not only the vessels. It's the vessels, even its bladder type tank or a compressed type tank, it has to be equipped with well-designed controlling system. And our advantage and features of this controlling system, it's the operation parameters of all auxiliary equipment such as control valves, temperature set points, pressure regulators, sensors, and actuators can be arranged according to commission requirements. Surge relief equipments can be optimized for correct capacity and set point of requirements. Method of operation can be investigated to determine if there will be resulting adverse effect which can be corrected before equipment is damaged. Valve operation time can be adjusted to minimize correcting transient pressure and to prevent vaporization of the product. Timing problems can be discovered and applied. Modification can be made during commissioning. Equipment response to pressure and flow updates can be investigated in detail, such as actual required relief volume capacity of the tank sizing purpose. And also, realistic pressure can be analyzed as per predecided values all along the pipeline during steady state and during transition between product flow rates and emergency events or other offset conditions. Leak risk and alarm levels can be checked in detectability. Leak detection system equipments and sensor location can be optimized, and detection limits can be determined during commissioning stage. And also accurate design response for equipments and pipeline in both study and state of transit conditions. If we want to list or specify the equipment that needs as a standard equipment for a bladder type storage vessel. The bladder type vessels shall and must be equipped with the follow equipment. Firstly, we must have the well-designed and high-quality manufactured pressure vessels. The pressure vessels must be designed according to the international standards and following standard quality and requirements. Secondly, we have to equip our vessel with internal bladder. The most important in this case is choosing the suitable material for the bladder and make quality manufacturing of it from the mean of the sizing, the nozzle, and load reinforcements. So the bladders can be manufactured from flexible polyvinyl chloride or butyl rubber or PU or PE materials. And also this material can be provided with food grade certificate and suitability for drinking and potable waters. And also our vessel must be equipped with magnetic level gauge, pressure safety valve, pressure control valve, pressure gauge, and ladder with platforms for maintenance purpose according to the size of the vessels. As we see in these pictures, some of type of the bladders, the PE and fluoride chloride, PVC bladders, and butyl rubbers, and PE materials. We can release from these pictures the sizing and manufacturing quality is most important item in bladder type storage vessels. For compressed type storage vessel equipment, as we indicated before, we need the pressure vessels. It also needs to be designed and manufactured according to international standards and following the requirements of this standard in mean of manufacturing, certification, and quality. And we also need a compressor system with piping and sonolite activated valves, control panel, magnetic level gauge, and pressure safety valve. And also we will need pressure control valves and check valves, pressure gauge, and ladder with platform for maintenance purpose for high size and capacity of surge protection systems. Now I will leave our screen to my senior design manager, Mr. Tunç, to follow and continue with you the design and transit analysis requirements and all the subjects with explanation on design and calculation of the surge vessels. Thank you for listening.
Thank you, Mr. Mohammed. Mr. Tunç Türeli, you can continue. Also, if you have any questions, if you want to ask us a question, you can write your questions from the chat button below. We will answer all of your questions after the presentation. Yes. Tunç Bey, your voice is closed. Mr. Tunç? Yeah.
Okay, we can start. My screen seen?
Yes, we can see it.
Okay. Hello, everybody. Welcome to our Search Vessel webinar. We are glad to see you here. I would like to kindly introduce myself to you. I am mechanical engineer as well as international welding engineer. Especially, we are working in the oil and gas industry as well as completed several different kind of industrial projects as engineering, procurement, manufacturing, and commissioning activities. We are the experts having a high competency in engineering and its standards, especially storage tanks and its equipments, pressurized equipments, as well as transportation systems. Today, I am trying to give you some technical briefs related to the importance of the technical investigations on transportation systems. As Mr. Mohammed explained, the search vessels positioned at the downstream act as a balance tank, protecting the system from the pressure rises, as well as vacuum cases, which is generated by the surge waves in the line. How this surge waves to be formed? While the line transfers a specific quantity of flow, the system philosophy is interrupted due to significant consequences such as pump trip, rapid valve closure, obstruction in the system due to instrument or equipment failures. In presence of this event, the flow momentum is supposed to be stopped. As a result, the liquid direct transfer to the reaction force to the line. As you're aware, the liquids cannot be compressed and generated force directly attempting to damage the line, trying to release from the weakest point of the network. As a result, this transferred forces in the liquid has an impact at every point along the line. In such a situation, we can basically say that considering velocity of the flow is nearly 3 meters per second. If the flow velocity is 3 meters per second and the line is longer than 300 meters, pressure increase would be raised 3 times of the operating pressure by the surge impact. That is a very general concept. However, if we are going inside of the details, the transient analysis is the most important evaluation study for the pipelines, particularly high capacity transfer lines, search waves, maximum and lowest values that will occur based on the criteria determined on the lines can be evaluated with this analysis. Maximum available working pressure and design pressure are description used for the pressure vessels, particularly those used in industrial applications. The design pressure is determined as per the maximum operating pressure, your system pressure, MOP, which is often raised by a margin to compensate for unexpected pressure surges. Calculations are performed as per the design pressure, and maximum available operation and working pressure is developed by the design pressure. MAWP is the maximum pressure at which the vessel or equipment may work at certain temperature and is defined by the design guidelines such as ASME Section 8 Division 1 or Process Equipment Directives. Here is the some of the condition I would like to inform you. This is basically you can determine some kind of the points whether your system needs search analysis or not. Especially transient analysis should be performed if pressure are more than 10% above the maximum allowable operation pressure of your pipeline. The following are some of the events that require transient analysis. When there is an upset condition, pressure more than 10% of MA operation pressure are noticed or recorded or monitored. Lack of redundant system, bypass line, and the simple manual techniques to prevent unexpected system response. If your system is not basic, meaning that would be operated by the sum of the systems, of course there will be some connection problems and the mechanically systems will be deactivated. For this reason, if you have such kind of control systems or instrumentation, you should better to perform such kind of transient analysis. If you have many years of expertise of your operating your system, have never experienced any overpressure or the future plans to undertake any major operational modification in the future, there would be no need to perform analysis. However, in any case, as a fluid dynamics, including the fluid dynamics and network system, should be performed in the this analyzing. Utilizing this search vessel search data, the determined scenarios which could damage the transfer lines can be predicted and precaution undertaken according to these cases. The detection of these weak nodes may not be observed in advance on hydrotest because sudden rising wave effect generates a different reaction than the hydrotest results. Also, interestingly, it is also possible to see scenarios when waves overlap and create higher pressures during fluctuations in accordance with the network topology. When this opening, there will be some combination of the waves, and these waves in the network can overlap each other and making the pressure rise at that areas further. I would like to show you a video demonstrate that how these issues might arise. We are performing our the mechanical calculation as per the international standards, and following this standards, we are performing the quality test. As you can see, there is a basic, simple transportation line. Here is the level decreasing. At that moment, the regarding signal is activated the instrument, and the system supply pumps is starting at that moment. It's vacuuming from the storage tank and pumping to this tank. However, in this time, regarding instrument, the closing action needs to be performed and calculated as per the closing time. This closing time is very important. If you are putting that one without performing the transient analysis, you cannot estimate if there would be, whether there would be the pressure surge or not. In this scenario, as you can see, this instrument is closing very rapidly, and this fluid momentum coming to this area and sending this surge wave to system. However, if we are performing our surge system, it is directly balancing the system pressure by the pressure increase and decrease by the automation system. This is the both bladder and as well as compressed type we can achieve as per your request, because system is needed some of the gas not coming to inside the solution inside of the vessel. We are utilizing to such kind of bladders type equipments. Completely controlled by the SCADA system. As you can see, during occurrence of this condition, this high velocity mass surge is looking for the weakest region of the line at the junction points, especially, and causes the line to fail points. Moreover, the collision effect causes significant damage to the operating equipment. When faced with these conditions, which produce numerous problems in the infrastructure as well as substructure, because it is going to be explode, and it becomes obvious how critical to do a preliminary analysis to define the needs of the system in this analysis. Here is the general acceptance criteria for the transition pressures. The fluid velocity exceeds 3 meters per second. If there would be some possibility of the pump or driver fail, possibility that valves will fail, instrumentation or some of the control valve can be problematic at that moment. Also, the used equipment's safety factor is less than 3 times of the operating pressure. If an emergency shutdown system is in use, as I explained in the video, there would be directly stop the system by some of the emergency shutdown cases. Valves between high pressure and low pressure between each other, rated piping or equipments. The points in the piping where the pressure lower than the vapor pressure. Normally, you cannot estimate such kind of the issues without transient analysis. For this reason, that is important case. If you are seeing the voice or some noise, some problematic issue in the equipment, the cavitation, that is showing that there needs to be a certain transient analysis requirements. If pipes extend for more than 300 meters, also surge protection is needed by the specification or the design codes. One of the most critical parts of such a transfer system is that the mechanical design have to comply to the given specifications. At this time, it is critical to examine the linkage factors such as temperature, pressure, and fluid composition. Examination such as finite element analysis and computational fluid dynamics should be carried out in accordance with the appropriate standard guidelines. Especially more effective control system is provided when it is required to limit high pressure passage utilizing restricted orifice evaluation at the inlet. All of our network and transfer analysis are performed utilizing appropriate in-house and international validated softwares to ensure compliance to the relevant directives. We are utilizing a combination of our software tools as well as the Bentley Hammer, AFT Impulse, and PV softwares. Because system parameters we utilize in analysis are interconnected with each other. Multiple parameters must be used at the same time. Mechanical, physical, pressure, chemical resistance, flow, temperature, and fatigue evaluation should be done simultaneously. As a result, it is critical to have a solid technical background in order to provide turnkey solutions and promptly reflect changes in the system parameters to calculations whenever needed. On the image, you can clearly see how the surge wave distribution transfers when the surge vessel is utilized in the basic transfer system. These are the same spec. Regarding pressure of flow at the wave, the pitch is going to be increased. Here's a vertical bladder vessel. I would like to give you some sample. The most important of all bladder types, working independently from the operation, the simplicity of manual operation and maintenance, separating liquid and gas contact. This is the most important part of this type of bladder vessels. Ensures that the flow quality in the system is maintained in a clean way. There are several bladder types of various type of liquids, as Mr. Mohammed explained previously. Here is the horizontal bladder vessel. Also, if any vacuum case observed in the system, as per the transient analysis, special bladder designs to be performed for accumulating the vessel with liquid and discharge whenever needed. Here is the horizontal compressor type vessel. This type of vessel are especially utilized high flow rate and pressure transportation systems. The arrangement of the automation system and its control philosophy with a series of opening and closing sequences needs to take into account the variation for the surge waves. As a result, interconnected technical systems are operating harmoniously with each other, and the combination of the supported systems absorbs the effects of the surge waves in a small period. To clarifying this procedure, various levels are determined in the vessel, and there are some the elevation inside of the vessels. During normal operation, all of them either open or closed. This instrumentation system controlled by the operation system. When a surge wave occurs, the valve begin to change their position from open to closed, or vice versa. For example, when a surge wave reaches a surge vessel, the pressure increases and gas area decreases. That means forcing connected air valves to open and release some of the pressure, and wave impact to be absorbed, by the way. On the contrary, when the liquid in the vessel decreases, as gas intake is provided to prevent low pressure in the system and to balance the pressure balance in the system. You can see a flow chart here regarding the procedures and timelines we use it for the investigation we perform. We perform budgetary analysis when this work's coming to us, and the analysis according to the fundamental concept that we have established during the estimating procedure. It is now necessary to develop hydraulic analysis in order to place the system properly. The system responses are then changed after research on the chosen equipment, and methods are established. Following the required analysis, mechanical calculations are performed to establish the surge vessel design. In order to ensure that design drawings are reviewed in accordance with the necessary code, directive requirements, they are prepared and submitted for the approval of the third party, and the site field is being worked on for settlement and automation, and the commissioning procedure will have startup. With our employees having different areas of expertise, we can move our projects along in a coordinated manner. The appropriate team members carry out updates as though essential, and we make sure that suitable solutions are presented as quickly as possible. We are anytime supporting to you as a technical base. Anytime you need to ask as a technical base, we are here. Thank you very much for your kind attention.
Thank you, Mr. Tunç Türeli. Do you have any questions? Actually, we have one. The question is, we actually answered in Friday, but maybe Mr. Mohammed Hassan answer it verbally again, publicly again. So question was, is there any measures considering potable water system and surge vessel design?
Yeah, for sure, there is requirements to be followed. If it's a bladder type system, the bladder shall be food grade certified, and the internal lining of the vessel must be also food grade or stable for portable water with certification. And also it's must be for the compressor type. The internal lining and the components which is in contact with portable water must be chosen with materials or lined with suitable paint of portable water. There is some certification for the paint as a WRAS certified paint and application. We're performing that application and using this certified paint.
Thank you. Are there any questions? Not. So, thank you for joining our webinar. Then we are going to keep make it happen that again and again. Webinar series. Another one. What is the difference between surge vessel and the expansion tanks?
As in webinar and we explained, the surge vessel is a protection for the surge waves and the hammering waves. It's blanketing and providing the extra water or liquid to the system, and also make blanketing and protect the system against the surge waves. But expansion tanks, it also feeds or balancing the water or hot waters from the system. The expansion tanks are used only for small buildings which have a heating system or a hot water system. So you cannot use the expansion tank instead of surge protection system, which is a complete design system with surge analysis requirements and providing the best protection for the pipelines and pump stations.
Okay, another question. What are the design differences between ESME and EN? Maybe Mr. Tunç Türeli can answer that.
Of course. Here is according to requirements of the related client requirements, we are providing both kind of the ASME and EN designs we are performing. However, these are the mechanical standards of the vessel, and one of them is the American standard, and other one is the Process Equipment Directive European norm. This European norm is sending us to three of different kind of standards, pressure standards. At Mark Blatter EN 13445, and most of the standard is performed according to this mechanical designs, and that is very important for specializing the regarding thickness as per client request and the locality authorities.
Okay. Thank you, Mr. Tunç. Are there any questions? I don't want to miss. Yeah. Another one. In which conditions do we need AWWA certificate bladders? Tunç Bey.
Here is this standard by the again American standard, and the requirements according to requirements of this standards, we are following the regulations and the directives given. There would be some certification, of course. For example, WRS certification for potable water. Also, this AWA certified bladders is the another requirements. This is the regarding to important part is the can be certified this certifying these bladders, and we can achieve according to directives, each directives.
Okay, thank you. Any other questions? Okay. Then thank you for joining our webinar again. Then see you next time. And Mr. Tunç and Mr. Mohammed, thank you for your efforts.
Thank you very much.
Thank you all for attending.
Bye bye.